helpful to you to have yesterday's note sheet out just to have that factoring techniques box to look at. Today we are solving polynomial equations by factoring. So when or if we need to factor, say, a sum or difference of cubes or anything like that, the formulas are on your sheet from yesterday to look at. So it might be helpful to have that out to reference. Okay, but as you're getting that out, a little preview into today. So I did mention, or at least I think I mentioned, if I didn't, I meant to yesterday. And I've talked about this idea before. The reason why we factor is to solve equations. So factoring was a method that we could use to solve quadratic equations. We can now apply those same techniques to solve polynomial equations. So the whole idea with factoring, when you have an equation, is to make sure you get one side of your equation equal to 0, which in example 1, that's already the case. Once one side is equal to 0, factor the other side so that you can use what we talked about in chapter 4, the zero product property, which means you set each factor equal to 0 to solve for your variable. So that's the reason why we went through those factoring techniques again yesterday. We're going to apply that now to actually solve equations today. So if we look at example 1, solving this equation, x cubed minus 64 equals 0. So again, one side's already equal to 0. Now the reason why you need to use factoring to solve this, this isn't formally talked about in this section. I'm going to preview it with you right now because it'll help you for today as well. When you have a polynomial equation, what is the degree of this polynomial? So this is kind of review. The degree is 3, the highest exponent. What that means is that this equation has 3 solutions. Okay, so this will be formally talked about later in this chapter. I'm just referencing it now to help you out. So whatever the degree is, that's the number of solutions there are. Now that doesn't mean that all solutions are real. You could have imaginary solutions. So it's tying in imaginary numbers as well from chapter 4. So if you even want to make a note, they could be real or imaginary. It could be a combination of real and imaginary. It could be all real. It could be all imaginary, but there's 3. So the reason why we have to factor to solve this equation, because you might be looking at this equation and thinking, well, why can't I just add 64 to both sides and then take the cube root? You could, but it's only going to give you one solution, and there are 3. So to find all 3, you have to solve this by factoring. So to solve this by factoring, and if you have your sheet out, from yesterday, this will help. So I have 2 terms. So I would check for a difference of squares or a sum or difference of cubes. I can see since I have x cubed, I would check for a difference of cubes. So I know x cubed is a perfect cube. The cube root is x. Is 64 a perfect cube? Or what's the cube root of 64? 4. Okay, so I can factor a difference of cubes. And I'm not going to write the formula up here. It's on your sheet from yesterday. Again, you don't have to have it memorized, but if you're wondering where I'm getting this from, it's from that formula we had yesterday. So with a difference of cubes, the formula starts out to factor it with a minus b. In our case, that would be x minus 4. That's one factor times, and then it's a squared. So in our case, that's x squared, plus a times b, which is going to be x times 4, or 4x, plus b squared is 4 squared, that's 16. And then I have equal to 0. And I know I mentioned yesterday at least once, once you factor a sum or difference of cubes, this is fully factored. You can't factor this any further. So that's as much factoring as we can do. So from here, I can use the zero product property and set each of these factors equal to 0 and say this means either x minus 4 is equal to 0 or x squared plus 4x plus 16 is equal to 0. And then I would solve these two equations for x. So the first one is much simpler than the second. Add 4 to both sides. One of the solutions is x equals 4. The other equation, this is a quadratic equation. Hopefully you can recognize that it's in the form ax squared plus bx plus c. How do you solve a quadratic equation? So this is referencing last chapter. How do we solve equations like this? We had multiple methods you could use. Quadratic formula, yes. So one method was to factor, but that's why I said this is fully factored, meaning this cannot be factored any further. So when you can't solve by factoring with a quadratic, you can use the quadratic formula. Okay, so quadratic formula as a refresher, because you don't have to memorize it. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So applying that to this quadratic equation, my b value is 4. So the opposite of b is going to be negative 4 plus or minus the square root of b squared. So I'll just solve that right away. 4 squared is 16 minus 4 times a is 1 times c is 16. And that's all over 2 times a, which is 1. And then this is now a matter of simplifying. So I have negative 4 plus or minus inside the square root. If I simplify 16 minus 4 times 1 times 16, that comes out to be negative 48. And that's all over 2. Now, I have the square root of a negative, which means what? It's imaginary, so I need to take the I out of it. You don't want to leave a negative in a square root. So this is negative 4 plus or minus, and I can write this as I times the square root of positive 48 all over 2. And then since 48 is not a perfect square, I'm going to leave my answer in a form like this. I want you to leave it in exact form, not give decimal approximations. But I would have to check, can I simplify the square root of 48? So is there a perfect square that goes into 48? And I do still have the first 10 perfect squares on the board up here. I think I heard somebody whisper it just now. I will sit here and wait with you. You can figure this out. Is there a perfect square that goes into 48? Thank you. Okay, I can split it into 16 times 3. Square root of 16 is 4. So I have negative 4 plus or minus. This then will become 4i times the square root of 3 all over 2. And then I should just make sure I can't simplify anymore. But when I look at this, 4, the negative 4, the 4, and then the 2 on the bottom can all be divided by 2. So I should do that. This will be negative 2. This would be 2i root 3. The denominator would just be 1, so I wouldn't have a denominator anymore. So overall, my solutions, I'm going to write them all together. My first one, I had x equals 4. or x equals, the simplified form of this is -2 plus or minus 2I square root 3. And do recognize this is 3 solutions here. So 4 is one solution. This represents 2 solutions here because of the plus or minus. So one solution is -2 plus 2I root 3. The other is -2 minus 2I root 3. So altogether I do have 3. So that's a way for you to check even starting today when you solve a polynomial equation. Whatever the degree is, that's the number of solutions you should have. So if you're solving an equation with degree 4 and you end up with 2 solutions, you know that you're missing 2 solutions. So you'd have to find where you're missing those 2. Okay, any questions on example 1? Okay, so then the remaining examples all focus around a specific form called quadratic form of a polynomial. So I first am going to practice with you in example 2, just being able to write a polynomial in quadratic form, and then the examples on the back are using quadratic form to actually solve an equation. So what it says on your sheet, it says in some cases you can rewrite a polynomial that has the variable x in a form where instead of your variable being x, you're changing your variable to u, and they just use u. But you can write it in the form au squared plus bu plus c. So this resembles the quadratic form that we used in chapter 4, ax squared plus bx plus c. So it says, for example, if we let u equal x squared, then this expression they're giving us, x to the 4th plus 12x squared plus 32, can be written as this form here. So notice what they're doing. They're taking x to the 4th and writing it as x squared quantity squared, because if we simplified that, properties of exponents, the exponents would be multiplied. That represents x to the 4th. And then 12x squared they're leaving. They're just putting parentheses around the x squared. 32 they're leaving. But why they're doing that is if u is equal to x squared, then these x squareds in parentheses can get replaced with u to get this expression. U squared plus 12u plus 32. Why are we doing this? You are taking a polynomial that has a higher degree, higher exponent than 2, and you're writing it as a quadratic expression because we just spent an entire chapter on how to solve quadratic equations. So rather than learning all of these new methods, part of writing this in quadratic form, that part is new. But then to solve it, you're using all of the methods or any of the methods that you already learned in chapter 4. You can solve a quadratic equation by factoring, by using quadratic formula, by completing the square, by graphing if you wanted to. So you're taking something that isn't a quadratic and writing it as a quadratic so you can solve it using those methods. So that's why we're doing it. And that's what this box explains, what I just explained above, quadratic form. I will say, I didn't notice this until I printed it. This is a terrible example, so please just cross that out. We are going to go through the examples at the bottom, but don't look at this example as a reference because it's not saying exactly what you need to know for quadratic form. Okay, so overall, like I said, your goal is to be able to rewrite it with u so that it's in the form a times u squared plus b times u plus c. Okay, so it's not possible for every polynomial. Here's how you do it and how you know if it is possible. So if you look at example A, to even know if you're able to do it, you have to look at the exponents on your x's, or on whatever your variable is. And the second term, that exponent has to be exactly half of the other exponent. So because my two exponents are 6 and 3, 3 is half of 6, I know that this one's going to work. I can actually write it in quadratic form. So then I have to determine what I'm going to let u equal. And u is always going to include x to a power, and the power on x comes from whatever the middle term is. So since the middle term includes x cubed, I know my u is going to include x cubed. Sometimes u will also include a coefficient in front of the x. In example A, it doesn't. It will in some following examples. I'm going to explain more in those how you determine whether there's a coefficient or not. I just want you to see the idea in part A here. So my entire u for this one is just x cubed. So to actually rewrite this in quadratic form, I'm leaving the 2 as is, so the 2 is just going to stay. But rather than writing x to the 6th, I'm going to write that as my u, which is x cubed, squared. And then I have minus, and in my middle term, I still have x cubed. I'm just going to include parentheses around it. And then the constant is always just going to stay exactly as it is, the plus 9. So when it asks for quadratic form, this is the quadratic form. How we're going to use this in the examples on the back to actually solve is you would then replace these x cubes in parentheses with u and write it as 2u squared minus u plus 9, because now this is a quadratic expression and you can factor or use quadratic formula to solve the equation if it was equal to 0. Okay, so it's kind of following that form. Takes some practice to fully understand it. If we look at B, can this one be written in quadratic form? Thoughts? I see some no's. Why not? Yep. 3 is not half of 4. The exponents don't work out. So in that case, you would just write not possible. So it's not always possible. It has to be in a specific form to begin with to be able to write it in quadratic form. All right, if we look at example C, can this one be written in quadratic form? Yes. Our two exponents are 8 and 4. 4 is half of 8, so this one will work. So when I'm choosing my u, this one's going to be a little different than the first one. I'm still, in my u, including the variable, which in this case is n, to the 4th power because that's in the middle term. So my u is going to include n to the 4th. This one, though, will include a coefficient. And here's how you determine if there's a coefficient included, and then if there is, what it is. So you have to look at your very first coefficient, in this case the 150. And I'm actually going to write out what you want to think of in case you want to write it on your sheet. You check for a perfect square factor. So kind of like what we check for when we're simplifying square roots, is there a perfect square that goes into that number, is what you want to ask yourself. So looking at the number 150, is there a perfect square that goes into 150? Besides 1. Caitlin? 25 goes into it. 25 times what? What's 150 divided by 25? 6. Okay, so I'm going to say 150, I'm just writing this, is 6 times 25. And 25 is a perfect square. So then if there's a perfect square that goes into it, then the coefficient of your u is going to be the square root of that perfect square. So if I take the square root of 25, that's 5. I'm going to include 5 as the coefficient as part of my u. So I'm going to try to draw arrows here explaining where these numbers are coming from. So 150 is 6 times 25. Take the square root to get 5. That's your coefficient of u. And then you should also make sure that this coefficient of 5 goes into the b term in this case, the 40, which it does. I know 40 is 8 times 5. Okay, so that's something to double check as well. So here's what the quadratic form is going to look like. It's going to look very similar to this one up here. I'm going to kind of write the base. I know I'm going to have some number times a quantity squared minus possibly some number times a quantity plus my constant, which in this case is minus 15. Okay, so here I'm going to fill in what I have. I know inside my quantity squared is the 5n to the 4th, is my u. The number that is now outside is no longer the 150. The number on the outside is going to be this 6. The reason why is if I were to simplify this or actually distribute the exponent, multiply it out, 5n to the 4th squared becomes 25n to the 8th. And if I take out the 25 from 150, I'm left with the 6. So that's where that 6 is coming from. Okay, then the middle term, again, I know in the parentheses, that's where u is going, the 5n to the 4th. And when I divided the 40 by the 5, I got 8, so 8 goes on the outside there. And then my constant of minus 15, that just stays. So this, let me just write it a little bit better. The quadratic form is 6 times 5n to the 4th squared minus 8 times 5n to the 4th minus 15. But again, why we're doing this is then if you replaced the 5n to the 4th with u, your quadratic expression is now 6u squared minus 8u minus 15. So this is what it becomes, and then you can factor, use quadratic formula. So I know it's a little different. Grace? Oh, it should not be. I thought this was a minus. Thank you. It should be plus. That sign wouldn't change from here. Thanks for noticing that. Okay, so I'm going to go through D with you as well, practicing this. So look at what we have. First of all, can we write this in quadratic form? Do some yeses. We have 4 and 2. 2 is half of 4. So u is going to involve x to the 2nd power. It could possibly involve a coefficient since I do have a number in front of the x to the 4th. So look at 8. Is there a perfect square that goes into 8? 4 does. And it's 4 times 2. So I'm going to write 8 is 2 times 4. 4 is the perfect square. So then what coefficient would be part of my u? Let somebody whisper it. 2. The square root of 4. And then just double check, does 2 go into the 12 coefficient? Yes, 12 is 6 times 2. So when I write this, for the first term, I know the u, the 2x squared, is going in parentheses, and that's being squared. What number is going to go on the outside of that parentheses? 2. So here from the 2 times 4, the 2 is going on the outside. And then I have plus, I know for the middle term again, in parentheses, I'm going to have u of 2x squared. What number goes on the outside for the middle term? 6. The 6 times 2, it gives you the 12, and then the plus 18 just stays. So this is the quadratic form. So if I actually replaced the 2x squared with u, I would have 2u squared plus 6u plus 18. Okay, so we're actually now going to use this in examples for how to use quadratic form to actually solve an equation. And between these two examples, my goal, I'm just looking at the time, I know it's Wednesday, we're a little shorter on time. My goal was to go through A with you and have you work through B. A is definitely the more challenging of the two, which is why I wanted to go through A with you. So when you have an equation to solve, it's already equal to 0. You see that you have a trinomial. There's 3 terms, but it's not a quadratic. We have a higher exponent. That's your hint that you should write it in quadratic form to then solve it so you can solve a quadratic. So I'm going to write this in quadratic form because I have exponents of 4 and 2, so it'll work. So I need to choose u. I know u is going to involve x squared. If I look at my 8, this is very similar to the one we just did. We already said 4 goes into 8, so 8 is 2 times 4. Taking the square root of 4 means my coefficient for u is 2, so u is 2x squared. And then 2 does go into 10. 10 is 5 times 2. So if I'm writing this in quadratic form, for my first term, I'll have 2x squared in parentheses squared. The number out in front would be the 2 from the 2 times 4. And then plus, for the middle term, again, I'm going to have the 2x squared in parentheses. The number in front would be the 5, since 5 times 2 is 10. And then the minus 12 stays. So this is the quadratic form, but now to actually solve this, I want to replace the 2x squareds with u. So my equation becomes 2u squared plus 5u minus 12 equals 0. All right, for this equation, you have a choice. I'm not telling you you must factor. I'm not telling you you must use quadratic formula. You have a choice now of what to use to solve this. I'm going to go through this with you and solve it by factoring, but when you work through these on your own, if you want to use quadratic formula, that's fine. If that's easier for you, that's okay. So I'm going to factor this. When I factor this, what am I multiplying to for the diamond? Negative 24. So when you have that number in front, you need to multiply the a and the c values, the 2 times negative 12. And then I'm adding to 5, 2 numbers that work. Negative 3 and 8. Now also remember when there's a number in front, some of you do this all the time regardless of whether there's a number in front. If there is a number in front though, you have to split the middle term. You can't just jump to u minus 3, u plus 8. That's not correct. So I have to rewrite this, keep the 2u squared, and then split the middle term using the negative 3 and 8. So minus 3u plus 8u, and then keep the minus 12. And the equals 0 even though we're not solving yet. And then factor this by grouping. So if I group the first 2 terms, all they have in common is a u. If I factor that out, I have 2u minus 3. And then 8u minus 12, they have a 4 in common, positive 4. Factor that out, and I'll have 2u minus 3. I'm going to leave off the equals 0 for right now. So fully factored, I have 2u minus 3 times u plus 4 equal to 0. Okay, and then I can use the zero product property, set each of these factors equal to 0. So 2u minus 3 equals 0, or u plus 4 is equal to 0. And then solve them both for u. So the first one, I'm going to add 3 to both sides, divide by 2. So u would equal 3 halves. Second one, subtract 4, u equals negative 4. All right, so here's where you need to think about a couple of things. First of all, look at your equation. I'll move this back if you're not quite done copying this down. Look at your equation to begin with. What variable are we solving for? What variable was in the original equation? X. I found u. These are not my answers. I did not find what x is. I found what u is. So here's where now you have to go back to what you chose as your u. U is equal to 2x squared. You have to now put the 2x squared back in for these u's so that you can solve for x. And look at your equation again too, based on what I talked about in example 1. How many solutions should we have? We should have 4, because the highest exponent, the degree, is 4. So that's another hint that you're not done because you only have 2 answers. So I'm going to replace u with 2x squared. So 2x squared equals 3 over 2, or 2x squared equals negative 4. Now I can solve these both for x. So I'm just going to focus on that first one first. To solve for x squared, or to get x squared alone, I have to divide by 2 with a fraction. That means I'm really multiplying by a half when I divide by 2. So x squared is 3/4. And then to solve this for x, I would have to take the square root of both sides. So x would equal, remember when you take a square root, you have a positive or a negative, so plus or minus. And when you take the square root of a fraction, you're really taking the square root of the top and the bottom. So I could write this as the square root of 3 over the square root of 4 is just 2. So then I wouldn't have a square root on the bottom. So that part is done. If I solve the other one for x, divide each side by 2, x squared would then equal negative 2. And then if I take the square root of each side, x would equal plus or minus. I have the square root of a negative, which means it's imaginary. Take out the I, so I square root 2. And then the square root of 2, there's no perfect square other than 1 that goes into it, so that's completely simplified. So these are your answers for x. You do have 4 because of the plus or minus. So plus or minus square root of 3 over 2 is really 2 answers. Plus or minus I root 2 is really 2 answers. Okay? Now, like I said, they are not all like this. This one, based on the choice of u, was a little more in depth. Okay, so I realize there's not a ton of time left. I would like you, with the time remaining, to start working on example B. I will walk around, I will answer questions, I will pass out the assignment, but at least use the last bit of time here to start working on it. That way, if you're getting stuck, you can get those questions answered before you go.